Okay, so today we've got another trig identity, and these are double angles. So our learning intention is to gain the knowledge of the trig identity of doubling the angle, and we'll be successful if we can correctly calculate and use double angle formula, and if we can derive the double angle formula. Okay, so what it means is if I have a triangle, yeah, and I have an angle of theta. If I then obviously double it and put this, the exact same triangle, right, and that is theta, this whole thing here would be 2 theta. Yep. Okay. So let's say I have a triangle, and that theta was called A. The angle, first angle is A. If I then have the other triangle, that's going to be A plus A. Well, we know from our previous lesson of sum and differences of angle, that's obviously sine A cos A plus sine A cos A. Because technically, if we had the old formula with B is actually equal to A at the moment. Okay, so if we look at this is sine A cos A, that's the same as that. Well, then that equals 2 sine A cos A. So the double of sine 2A is 2 sine A cos A. Okay. Same thing if we have cos of 2A, that's the same as saying cos A plus A. The sum of differences of angle is cos A cos B plus, minus, I'm going to change the sign, minus sine A sine B. But this case, there's no B's because the B's is technically A. So cos A times cos A, that's the square of cos A minus sine A, the square of sine A. So cos of doubling the angle is the same as cos squared A minus sine squared A. Okay, tan 2A, so that's going to be tan A plus A. Well, we know that that's tan A plus tan A, 1 minus tan A tan A. Okay, well, that's just 2 lots of tan A. And that's going to be tan squared A. Yep. So when we're doubling the angle, we're using the sum and differences of angles, where you can derive this identity of sine 2A is equals to 2 sine A cos 2A is equal to cos squared A minus sine squared A, and tan 2A is 2 tan A, 1 minus tan squared A. Alright. So if we have tan A equals negative 3 over 4, and A is between 90 and 180. So the first thing I want to do is, I'll do it over here, is draw a triangle, and we know it's in the second quadrant, so it's over here. Okay, it is negative, so tan, there's your theta, is opposite over adjacent. Okay, we want to calculate cos of 2A. So using Pythagoras' theorem, we got 3 and 4. We know that the hypotenuse is 5. Okay, so cos of 2a, well, that's going to be cos squared a plus sine squared, minus sine squared a, using that identity. Okay, so cos is negative 4 over 5, all squared, and sine is 3/5. Okay, squaring that's going to be 16 over 25 minus 9 over 25. That's going to be 7 over 25. Still using our example, well, we want to figure out what sine 2a is. Well, sine 2a is 2 lots of sine a cos a. In this sense, sine a is 3/5, and cos a is negative 4/5. Multiply that across, we get negative 24 over 25. Okay, so tan 2a, well, that's equal to 2 lots of tan a over 1 minus tan squared a. So tan a in this sense is negative 3 over 4 all over 1 minus negative 3 over 4 all squared. So that's going to be negative 6 over 4 divided by, that's going to be 9 over 16. 1 minus 9 over 16 is 7 over 16. Yeah. Keep, flip, change. So it's negative 24 over 7. Okay. We want to find the exact value of sine of 2x. Okay, so if sine of x equals 5 over 12. So we draw our triangle. Yep. We've got opposite over hypotenuse. Using Pythagoras, I can find out that that's 119. So 144 minus 25, square root of 119. And we want to find sine of 2x. So sine of 2x equals 2 of sine x cos x. Okay, sine of x is 5 over 12, and cos of x is 100, square root of 119 over 12. So that gives us 10 square root of 119 over 24, and we can simplify that. Okay, here is, we're going to show that 2x equals 1 minus 2 sine x. Okay, so cos of doubling the angle is the same as squaring the angle minus sine of the squared. Yep, okay. Now, using the Pythagorean identity, that cos squared x plus sine squared x is equal to 1. And that comes from obviously the unit circle. So technically we can say that that is the same as 1 minus sine squared x. Okay, so instead of writing cos squared x, I'm going to write 1 minus sine squared x. I didn't touch that, so that just stays the same. Okay, so that's going to be 1. They're the same, so that's 2 lots of sine squared x. So I've shown that cos 2x is equal to 1 minus 2 sine squared x by using the Pythagorean identity. Okay. Alright. We want to prove that cos 3 theta over sine theta plus sine 3 theta over cos theta equals to 2 cot 2 theta. Okay. So looking at the left-hand side, I'm going to add these fractions by multiplying. So we've got cos, let's just do 3 theta first. Cos theta plus sine 3 theta sine theta all over, so this is the left-hand side, sine theta cos theta. Okay. And that's the same. We can write it like this. We can go before I do that. Okay, so notice this. Yeah, okay. So if we notice this is cos cos, sine sine, they're the same. That's actually a sum of an angles. So that's actually 3 theta minus theta. Okay, so 3 theta minus theta is going to be cos of 2 theta. Because I want to get a cot on the right-hand side, I want my answer to somewhat look like, I want it to be cos something over sine something, because that would be cot. Okay, so really I want to be looking at something and trying to really want to cancel off the cos theta at the bottom here, yeah? And so if I use the identity of sine 2a equals 2 sine a cos a, yeah? And if I divide both sides by 2 sine a, I get sine 2a over 2 sine a cos a. Okay. So what I'm going to do is, rather than using cos theta, I'm going to replace it with this stuff here. So I've got cos 2 theta all over sine theta multiplied by sine 2 theta, because a is theta at the moment, over 2 sine theta. Okay. Well, this cancels out this. Okay. And now, so that gives me cos 2 theta over, I'm just going to take out this divide by 2, because that's the same as like a half times sine 2 theta. And we're nearly there, because I've got a sine 2 theta, cos 2 theta over sine 2 theta. Yeah, so I really have this cot 2 theta at the end. Okay, because that's that part. But we've got a 1. 1 divided by a half is just 2. Okay, and so then that's the the right hand side. So cos 3 theta over sine theta plus sine 3 theta over cos theta equals 2 cot theta. So cot 2 theta. Okay. And that's it. Thank you very much.